In a world where you can Google literally anything in seconds, does just knowing a bunch of facts still matter? Today, we're going to dive into a massive shift in how we think about learning. It's about moving away from just memorizing stuff to building a skill that is absolutely essential for the 21st century: knowledge construction. Let's get right into it.
So, to really get where we're going, we first have to understand where we've been. See, a lot of our education systems, they were designed for a totally different time. Think the Industrial Revolution, a time when information was actually pretty hard to come by. And this really gets to the heart of the challenge, right? The old model was built for information scarcity. A teacher's main job was to pass down a known set of facts. But today, we're not just getting information, we are drowning in it. The game has completely, fundamentally changed. In just how much has it changed? I mean, take a look at these numbers. Every single minute. We're talking nearly 700,000 Instagram stories, 500 hours of video uploaded to YouTube, and almost 200 million emails sent out into the world. In an environment like this, just trying to remember facts isn't just a bad strategy, it's impossible. Okay, so if the old way is broken, what's the alternative? The goal of education has to change, right? It's got to move from just repeating information to something way more dynamic, way more powerful. It's time for a new goal for every single learner out there. And that new goal is something called knowledge construction. Now, what's so cool about this idea is its focus on creation. It's not about just spitting back what you've been told. It's about generating ideas and understandings that are brand new to you. So what does this actually look like in a classroom? Well, a knowledge reproduction task might be, hey, write a report on what you found. You go find info, you report on it, straightforward. But a knowledge construction task asks something different. It says, evaluate the credibility of these different stories about the same event. See the shift? One is just repeating, the other is about using your judgment. And now, this isn't some fuzzy, abstract idea. Knowledge construction is built on a foundation of real, teachable skills. These are the things we often lump together and call critical thinking, and they are the absolute pillars of this new way of learning. So, how do we actually do it? How do we build knowledge? Well, it really boils down to 4 core skills: interpretation, analysis, synthesis, and evaluation. These are the tools in the toolbox that every learner needs to build their own understanding. Let's break them down. First up, you've got interpretation. This is all about reading between the lines. It's not just about what a text says on the surface, but what it implies. So, for example, instead of just listing facts about a historical period, a student starts to figure out why people acted the way they did based on the world around them. Next up is analysis. This is the skill of taking things apart. You take a big, complex idea and you break it down into all its little pieces to see how they all connect and work together. Like a science project where you have to figure out which specific environmental factors out of dozens are the ones that really affect migrating birds. Then you have synthesis. So if analysis is about taking things apart, synthesis is about putting them back together in new ways. It's about spotting the connections between different ideas. A classic example is when you read a bunch of different sources on the same event and build a much bigger, more complete picture by comparing all those different viewpoints. And finally, we have evaluation. And honestly, in our world today, this might be the most important skill of them all. This is your built-in fact checker. It's the ability to judge what you're seeing. Is this source legit? Is this data trustworthy? Does this argument actually make sense? This is our #1 defense against misinformation. But wait, there's more. Building knowledge is really just the first step. The real power, the real deep learning, happens when students start to apply that knowledge and connect it across completely different areas. This is where things get really exciting. The first part of this deeper learning is all about application. I mean, it's one thing to understand a concept, but can you use it to solve a problem in a totally new situation? For instance, imagine a student learns about physics by studying Earth's core and then has to use those same principles to figure out what's happening on Jupiter. That's a real test of understanding. The second part is making what we call interdisciplinary connections. Think about it. Real-world problems almost never fit neatly into one little subject box. So why should our learning? You can't truly understand Renaissance art without also understanding the history, the economics, and the culture of the time. Connecting those dots creates a way richer understanding of the world. Okay, so I know what you might be thinking. This all sounds fantastic, but how can a teacher actually do this in a classroom? How do you even measure this kind of learning? Well, lucky for us, there's a really powerful and practical framework we can use. And here it is. It's a simple decision tree that basically acts as a roadmap for educators. It lets them look at any assignment or activity and figure out how much deep thinking it actually requires. Let's walk through it real quick. So, the very first question is the most basic one. Does this task ask students to do anything more than just repeat information? If the answer is no, if they can get it done just by remembering a fact or following a simple recipe, then it's a level 1 activity. It's pure reproduction. Okay, let's say the task passes that first test and does require some real thinking. The next question is that thinking the main part of the assignment? If students are spending most of their time just gathering facts or, making the PowerPoint look pretty, then it's a level 2. Now, if knowledge construction is the star of the show, we move up the ladder. Now we ask, are students required to take what they've learned and apply it to a new, unfamiliar situation? If the answer is no, it's a really solid level 3. They're definitely building knowledge, but they're keeping it in the original box. And finally, if they are applying their knowledge, we ask one last question. Does this activity cross subject boundaries? If it stays within, say, just science, it's a level 4, which is a very, very strong learning task. But if it forces them to connect ideas from different fields like science and history, that's a level 5. That's the gold standard. And here it is, the whole thing laid out. This 5-level rubric gives you a super clear path for designing and evaluating learning. It helps educators be really intentional about moving students away from just repeating facts and toward complex, creative problem solving. It's a game changer for any classroom. So at the end of the day, it really leaves us with one big question to think about, whether we're teachers, parents, or just people trying to learn. In this age of infinite information, what kind of questions should we be asking? The kind that have one simple, Googleable answer, or the kind that spark our curiosity and inspire 1,000 new questions? The choice we make really will define the future of learning.